Hi everyone, so in this video I'm going to go over your review sheet for your second test. The first example says Professor Snape gave his class 3 mathematical rules shown below to prove or disprove which rules can be proved for all real numbers. So the best way to do this is just multiply it out. You could also substitute numbers in for m and p, x and y, and a and b. But the full-on correct way would be to multiply out the sides. So the side I can multiply out right now for this one would be this side for this side, and both sides for these guys. Okay, so what I'm going to do is I'm going to do choice 1 first. So I'm going to multiply m plus p times n plus p. I'm doing it out twice because it's a squared. So multiplying this with the box method, MP, MP, I'm going to get m squared, MP, MP, and p squared. This will end up getting me m squared plus 2mp plus p squared, which does check out. Okay, so I know that 1 works, so they want me to say which rules can be proved. So we know 1 works, so I'm not going to pick choice 2, which also, since 2, okay, so I'm left with these choices right here. Okay, so I'm just trying to do some process elimination here. And since choice C we had to eliminate because it tells us that 1 is not in it, I can also eliminate B because 2 is within this one as well. Okay, so the only other one I really need to go over is this guy. So I'm going to multiply out the left side. Okay, so box method that. So I'll get a to the 4th, a squared b squared, this is a 4th, sorry, a squared b squared, b to the 4th. These are like terms, so I'm going to end up getting a to the 4th plus 2a squared b squared plus b to the 4th. So that's one side. Now the other side is very similar, except it has minus, so it'll be a squared minus b squared times a squared minus b squared. Doing their box method, you'll get out, let me just move this so we have more space here. Okay, so you're going to get a to the 4th minus a squared b squared minus a squared b squared here, and b to the 4th. These will combine, so I'll be left with a to the 4th minus 2a squared b squared plus b to the 4th. And the last piece here is squaring that whole 2ab, which gets you 4a squared b squared. Now if you notice, these guys are like terms, so I can combine them together to get 2a squared b squared, and then a to the 4th and b to the 4th will just chill out, and these now match, so I know choice 3 is a choice that works. Okay, so the next section says factor, because you're going to use all your types of factoring. Of course, the first thing you always want to think of is GCF. There's no GCF in this one. It's 4 terms though, so I can split it down the middle and do grouping. I'm going to take out a k squared here because that's my GCF. I'll be left with k plus 5. On the other side, I'm going to take out something that will get me k plus 5, so I'm going to take out a negative 9. And I'll be left with k squared minus 9 and k plus 5. Now I want to make sure that I break it down completely, and I need to notice here this is dots. So this is k plus 3, k minus 3, and then k plus 5. And that's fully factored now. Next one, there are 2 terms, and the only types of factoring you can do with 2 terms are dots and cubes, which is the SOAP method. And because there are cubes here, see there's to the cube, this is a SOAP problem. So the first step, remember, is to take the cube root of the 2 terms. And when you do that, you're going to get h plus the cube root of 216. Remember, hit math, go to choice 4, you'll see the cube root. And the cube root of 216 is 6. And then g. Okay, so that's how I get my first one. This is h, and this was the 6g. All right, so now I'm going to write the word SOAP. OAP. Remember, this gives us our signs. So same, opposite, always positive. Okay, now to fill it in, you're going to think square, multiply, square. So I'm going to square this to get that. I'm going to square this to get that. So let's start off with that. So I get h squared here. I'm going to square the whole 6g squared, the whole entire thing. So that'll make this 36g squared. And then I'm going to multiply these two and get 6gh. That's very sloppy. Hold on. 6gh. And then you're done. Okay, so this right here is your completely factored form of that. Okay, next one. You should always think of GCF first. So is there a GCF? The answer would be yes. I can take out a 4. If you don't remember, hit math, num, GCD, 4, 64. You'll see 4 is the GCF. You'll be left with x squared minus 16. And then this is dots. It's dots because you see 2's perfect squares with subtraction in between. Next one, think GCF. Is there a GCF between 5, 4, and 12? No. So because I have a trinomial, I can either do AM or AC. But because there's a number in front of here, it's AC, which is like the glasses method, okay? So you're going to multiply 5 times negative 12 and get negative 60. You're going to think of your factors of negative 60 that add to negative 4. So if you want to see your factors, remember to put negative 60 divided by x in y equals, and then look at the table. And you'll see all your factors. So you see 1 and 60, you'll see 2 and 30, so on and so forth. 6 and 10. That's actually the pair we want. And because it's a negative 4, the bigger number will be negative. So I'm going to choose 6 and negative 10. I'm going to put the negative 10x next to the 5. It just makes more sense because 5 and 10 have that GCF. Now, I'm using an x here because, remember, this is the thing you're breaking up. You're breaking up an x. Then this turns this into grouping. Split it down the middle. Divide by 5x. That's your GCF here. You'll be left with x minus 2. That means you want x minus 2 on the other side. So I'm going to divide by 6. And you're going to take a 6 out. You'll be left with x minus 2. This is what is your binomial GCF. Pull that out. You'll be left with 5x plus 6. And there it is. That's your answer. Okay, this one is another 4-termed one. First off, think GCF, and there is none with all the 4 terms. So you're going to try to group. Now, things are not looking okay over here because you cannot take a GCF out. So because that's the case, you're going to have to move around the order. Now, normally I would say switch the ones that keep the signs in order, but it really doesn't matter which ones you switch. Some people switch the middle terms, some people switch the end terms. It's really up to you. I'm going to switch the middle terms with this one. I think on the key I switched the end terms, but you can get the answer the same way. Okay, split it down the middle, find your GCF. I can take out a 3 here. Be left with y plus 5. Now, if you notice, this is a positive y plus 5, so when I divide my GCF here, I'm going to want to take out a negative to make the signs positive, positive, and the GCF would be x. So I'm going to take out a negative x, and I'd be left with positive 5 plus y, which is a good sign because this here is the same thing as that. It just flipped order, and that's okay because it's commutative property. So this is your answer. All right, next question. Again, always think GCF first. Is there a GCF between 2, 8, and 90? The answer would be yes. You can take out a 2. What about the letters? Can you take out a letter between x the 5th, x the 3rd, and x? Yes, you can. You can take out an x. So I'm going to pull out a 2x here, and I'll be left with, these will cancel, x to the 4th minus 4x squared minus 45. Now, look at this thing on the inside. See how there's 3 terms here, and there's no number in front? This is still able to be factored. It's AM. Bring down your 2x, so you don't forget it. 2 sets of parentheses, x squared, x squared. We're breaking it up like this because we have an x to the 4th. What are your factors of negative 45 that add to 4? Well, that would be 9 times 5. I want a negative 4, so the 9 will be negative. And again, think, can you factor more? And you can, because this here is dots. So I'm going to do x plus 3, x minus 3, and then just drop everyone else down. And there you go. I think that's it for this page. Let's see. Yep, okay. Moving on. This is another factoring problem. This one's a little bit different, okay? And I've seen this a lot on the Regents and the SAT, the way that they write it like this. Think of it as 3 terms here. 1, 2, and 3. What type of factoring can you do with 3 terms? A, M. And you do have factors of 3 that add to 4. 1 times 3, okay? So the only tricky part here is you would do 1 and 3 and plus because that would add to 4. But the only tricky part here is the x plus a. And don't be frightened by it. Really, it's just going to put x plus a here and x plus a here. Think of it as like x and x. You would have x and x here. It's just an x plus a instead. Okay, and that's how you factor something like that. The next question says, write a quadratic function that is a reflection over the x-axis, translated left 4 and shifted up 8. So quadratic would mean that you would have to have parentheses and x and then all squared, because quadratic is squared. Reflected over the x-axis would make me have a negative in front, like a -1. Left 4 units is inside the house, so I'm going to do plus 4. Remember, positive means left. It's opposite of what you think. And then up 8, so plus 8. Okay. Just want to see. I just skipped from 4 to 6. That's good. That's okay, though. All right. So this question says, determine the quotient and remainder when this polynomial is divided by the other one, and they want you to express it as the quotient plus the remainder over the divisor, and that's just how you write when you have a remainder. So the first thing you're going to do is set up your long division, 3x plus 2 divided by 12x cubed plus 20x squared plus 11x plus 4. Try not to squish yourself in there. You're going to want to make all your math written out in a nice way. Okay, so first step is to divide. Remember, divide, multiply, subtract. Those are your 3 steps. Divide the first term by the first term. So 12x cubed divided by 3x. Okay, so 12 divided by 3 is, that is not right. 12 divided by 3 is 4x squared. We're going to put that up here above the x squared. So we divided, now we're going to multiply by the whole outer piece, so 3x plus 2. Distribute this in. So you're going to get 12x to the third, which should always match up, plus 8x squared. So we divided, we multiplied, now you're going to subtract. Change both signs. This will become a minus, this will become a minus. This will cancel. 20 minus 8x squared is 12x squared. Drop down the rest. Okay. Then you're going to divide the first term by the first term again. So 12x squared divided by 3x. Divide that, you get 4x. Add that to the top, because that's a part of your quotient. You divided, now you're going to multiply by the whole outer piece. Distribute this in. You're going to get 12x squared plus 8x. Change both signs. Minus, minus, because we're subtracting. Cancel that out. 11 minus 8 is 3x. Bring down the positive 4. Start all over again. One more step. 3x divided by 3x. You get 1. That's a part of your quotient. Goes up here. Then we're going to multiply by 3x plus 2. Distribute this in. You get 3x plus 2 here. You're going to change both signs. Subtract it. You're going to get 2. Okay. This is your remainder. So what do you do with your remainder? Just like it says over here, it's going to be your quotient plus your remainder over your divisor. So this is your quotient plus 2 divided by 3x plus 2. Make sure the plus sign's on the side, away from the fraction. Otherwise, it's not written correctly. Okay? They say now, is 3x plus 2 a factor of 12x cubed plus 20x squared plus 11x plus 4? No. Why not? There's a remainder. So you're going to say no because there is a remainder of 2. You would want a remainder of 0 for it to be a factor. Okay, next question. It's another division problem. You can always choose to do long division, but synthetic division is easier, and that's the one I usually lean towards if I can. And I can do synthetic on this one because there's no number in front, and it's just a number here. So it's linear, so I can do synthetic division. So first step is I'm going to set this equal to 0, find out what x is, x equals 2. So that's going to go in my box here. Then I'm going to take my coefficients, 4, -3, 5, and -8. So 4, space it out. Good. Drop down your 4. You're going to do 2 times 4 is 8. Remember, you add, so you're going to get 5. Then you're going to do 2 times 5, which is 10. Add, you're going to get 15. 2 times 15 is 30. Add, you'll get 22. So then you're going to drop this down by a power, so 4x squared and 5x. So it's going to be 4x squared plus 5x plus 15. And you're going to add your remainder to the end divided by your divisor, which is x minus 2. And there you go. So I hope this video helped you guys with your review sheet. Please come to extra help if you need it, and I'll see you soon.